The universe is a really complex and expensive structure with billions of stars, planets, and galaxies. And one of the most important things that act upon the universe are the fundamental forces. The four fundamental forces govern every object in the universe, even the ones that break space and time. They also remind me of Avatar, and I love Avatar. The fundamental forces are gravity, which is the weakest, the strong nuclear force, which is the strongest, the electromagnetic force, and the weak nuclear force. Everything in the universe emanates and is acted upon by these forces. Even you. That's right, you have a gravitational and an electromagnetic field. But you probably knew that already. I'll do my best to tell you something you probably didn't know, like gravity having an infinite range and still moving at the speed of light. I'll explain that later. I also have to say, this has been the most fun researching a subject I've had in a while. Mostly because it was easy to get the information I needed. A lot of smart people have already studied the hell out of this subject, so it's easy to find out what you need. Also, before I start, please subscribe, but no pressure. I'm going to talk about the forces from strongest to weakest, starting with. Before I continue talking, I just want to say I started to use background music. Could you please tell me what you think about it? The strong nuclear force binds together protons and neutrons in the nucleus of the atom, just like how a child keeps a dying marriage together. Without the strong nuclear force, most matter in the universe would not exist at all, because protons have like a positive charge and repel each other. Also, while the strong nuclear force is the strongest force, being over 100 times stronger than the second strongest force, the electromagnetic force, it has the shortest range. Its range being 10 to the negative 15 meters, or almost 1 femtometer, which is pretty small. I've never even heard of a femtometer till writing the script for this video. You learn something new every day. Before I continue, I would like to say you look absolutely dashing. Did you get your hair done? Because it looks amazing. We should get together sometime. Anyway, let me continue. According to quantum chromodynamics, the strong force is caused by particles called gluons interacting with quarks. Quarks are the fundamental particles that make up protons, neutrons, and other hadrons. I hope YouTube doesn't take this as me saying something inappropriate. There are also anti-quarks, but I won't really get into them, lest I want to get off topic. You also have to account for the strong nuclear force when creating a nuclear bomb. I don't know how though. Pretty sure most people don't care to learn how to build a nuclear bomb. You can Google it if you want though, nobody's gonna stop you. Also, another thing I forgot to mention, it might seem like the strong force only works on protons, but that's not true. It works on both protons and neutrons. Also, another name for the strong force is the strong interaction. Anyway, I think it's about time I moved on to the next force. Our second force and the second strongest force, the electromagnetic force, is the one I believe does the most amount of things. From making magnets to making light itself. Yeah, light is a really small part of the electromagnetic spectrum, only making up 0.0035% of it. It's crazy to think that that's the only part we can see. And when I mean light, I mean visible light. Also, if you're wondering, the electromagnetic spectrum is the entire distribution of the frequency or wavelength of electromagnetic radiation. A bit off topic, but some animals like shrimp can see more of the electromagnetic spectrum than humans can, meaning they can see colors we can't even imagine. I learned this fact when I was 9 and it blew my mind back then. And it's so fun revisiting those memories. Anywho, the electromagnetic spectrum encompasses many forms of radiation, the weakest being radio waves and the strongest being gamma rays. Yeah, like the ones that hit the Hulk. But unlike Bruce Banner, if you got hit by them in real life, you'll probably die a slow, painful death from cancer or something, which is probably a way you don't want to go out. I know I wouldn't. All of the wavelengths in order are radio, microwave, infrared, visible light, ultraviolet, X-rays, and gamma rays. It's impressive that people found a use for all of these frequencies. Really speaks to humanity's ingenuity and craftsmanship. The electromagnetic force also has an infinite range, like gravity. It's caused by positively and negatively charged particles interacting with each other. Positively charged particles repel other positively charged particles. Negatively charged particles repel other negatively charged particles. but positively and negatively charged particles attract each other. But you probably knew this already, so I don't know why I'm explaining it. One of the most obvious impacts of electromagnetism are magnets. I mean, come on, it's in the name. Magnetism can occur naturally, like in the case of the Earth or most other bodies in the solar system, or artificially from people. It's caused by electric charges moving around. I wonder if I'm explaining this well. Stay on your channel, so if you comment something, I'll read it and reply to it and give insight to any and all questions to the best of my abilities. Anyway, I think it's about time I move on to the next force. There? Alright, our third force, the weak nuclear force, is the one, to be honest, I knew the least about going into this video. And that's kind of surprising in hindsight, because it's an important component in nuclear fusion, the process that fuels stars and creates oxygen. And obviously oxygen is one of the most important things in nature for life. Anyway, the weak nuclear force does a few things, but one of the most important is radioactive decay. It allows particles to become other particles by changing up their quarks. I mentioned quarks earlier in this video, but let me explain them in further detail so I can explain the weak nuclear force better. Quarks come in 6 flavors: up, down, strange, charm, top and bottom. But for our purposes, we just need to focus on the up and down quark. Kind of weird that I initially avoided talking about quarks in depth earlier in this video, but now I have to. Anyway, protons and neutrons have 3 quarks each. Protons have 2 up and 1 down, and neutrons have 2 down and 1 up. Sometimes when a particle is close to another particle, a quark will emit either a W or Z boson. Most of the time this boson will just decay into another particle, but rarely it can go into another quark and turn that quark into the opposite quark. It's also the only force that can tell if a particle is an antiparticle or a normal particle. It's also the only force that can tell what a particle's spin is. The weak nuclear force is far more complex than I'm explaining right now, but I think you have a decent mental picture of what it is and what it does by now. And again, I will answer any and all questions you might have in the comments to the best of my abilities. But I do recommend you watch these videos by FamilyLab in order to get a more in-depth understanding of the weak nuclear force. He's got a lot of videos on particle physics and I like on his YouTube channel. Anyway, I think it's about time I move on to the next force. Alright, let's be honest, we both know what gravity is, what it does and how it operates. But this video is about all the fundamental forces, and that includes gravity. Even though gravity has been covered extensively, especially here on YouTube, I'm also excited to talk about it because it's one of the coolest and most interesting topics science has to offer. Besides, I don't know, what was the first person to ever drink cow's milk thinking? That guy was probably a weirdo. Like, you don't wake up one day and decide to drink your cow's milk. Oh yeah, I was talking about gravity. Gravity is an invisible and omnipresent force that influences everything from the tiniest of protons to the most massive of stars, connecting anything and everything with each other. Gravity is caused by an object's mass, or more accurately, an object's mass bending space-time. A common depiction of this is space-time being 2D, but a more accurate representation is space-time being more 3-dimensional, like this. Everything in the universe exerts gravity upon everything else in the universe, pulling everything towards each other. And even though gravity has an infinite range, things can only move towards each other at the speed of light. In my humble opinion, gravity is the coolest force, even though it's the weakest by far. I don't even have a quantifiable measure on how weak it is. That doesn't mean it's not important though. Stars form due to gravity when clouds of gas in space collapse in on themselves. The strength of gravity is also dependent on an object's mass or energy. The more mass you have, the greater your gravitational pull. And the closer you are to an object, the stronger your gravitational pull. Gravity is also the most responsible for the evolution of the universe to its current state, at least the way I see it. I mean, it forms stars, planets and solar systems, but not galaxies. A common misconception is that gravity holds together galaxies, but that's not true. Galaxies are held together by something called dark matter. The supermassive black holes in the center of galaxies simply don't have enough mass to make everything stay together. I won't go into depth about dark matter because it's a bit out of topic, but here's a proper definition. Alright, I hope you liked this video and I hope I did a good job in explaining stuff. I'm not very good when it comes to talking to people, so every time I record I jumble up my words a lot. Even so, every time I record I'm always happy about it. Also, in the last video I said I would post links in the description of the video to the sources I used, but I found a few technical difficulties while trying to do that. So I'm just gonna show you a few of the sources I used at the end of this video right here. These are the sources I used for the strong nuclear force. These are the sources I used for the weak nuclear force. These are the sources I use for the electromagnetic force, and these are the sources I use for gravity. Here are some videos I recommend if you're interested in learning more about particle physics or the fundamental forces. And here are some videos I recommend if you wanna learn more about gravity in particular. Anyway, thanks for watching and goodbye.